Hello, everyone. Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I'm joined by my other host,
Ben Wilson.
And today we're going to have a panelist discussion about spikes. So, not volleyball, not like a spike in the ground. We're going to be talking about research spikes.
Hey folks, this is Charles Maxwood. I've been talking to a whole bunch of people that want to update their resume and find a better job. And I figure, well, why not just share my resume? So if you go to topenddevs.com/resume, you enter your name and email address, then you'll get a copy of the resume that I use, that I've used through freelancing, through most of my career, as I've kind of refined it and tweaked it to get me the jobs that I want. Like I said, topenddevs.com/resume will get you that. And you can just kind of use the formatting. It comes in Word and Pages formats, and you can just fill it in from there.
And so what is a research spike? Well, you are an ML engineer, and you're a very busy ML engineer because most people are just busy people. But as the good ML engineer that you are, you read blogs on the weekends. And one of these blogs has a really cool method that promises 100% accuracy without overfitting your data, takes 1 second to run, and you actually don't have to write code for it. So you bring this to your manager and say, hey, maybe we should try out this method. Your manager says, let's do a spike. That's the scenario. And I think, Ben, we can go from there. So what is said term spike?
I don't know the genesis of it. I just have used them in Jira before. So when you're doing sprint planning, you have some implementation that you either want to consider or is planned in the future, like maybe 1 or 2 sprints later, or it could be next quarter. You can, and I have worked in teams where nobody does research beforehand. I don't think that's adhering to the Agile method, but it's more like, hey, we know we need to build this thing. Let's just guess at story points, and then we'll put it on, 2 sprints from now. But the more successful teams I've been a part of, people set aside some amount of time. Either an individual who's going to be doing the implementation does it on their own, or the fun one, which is the whole team sits down and responds to some pressing need from customers, whether they're internal or external to that development team, of saying, hey, we'd really like this functionality, and end of story, period, end of sentence. And the team's like, all right, we need to figure this out. Like, is this worthwhile? What are our shortcomings? Let's take some limited time boxed amount of time and see what we can figure out.
Yeah, and I've seen a bunch of different methods for this. At a prior role, we had something called a rotating hermit, where they would just not sign into Slack, not attend any meetings, and for that week, they were tasked with delivering an insight, implementing a solution, or something like that. That was really fun, but it was definitely low on the collaboration scale. So another method we did were hackathons, and they were roughly every 2 quarters, sometimes every quarter, and it would be looking to solve, especially creatively solve, large business issues. So why is this happening with a given team? Can we attribute success or growth in the company to this specific initiative? That's a really hard one that executives love to try to solve with data. But there are many different ways to go about it. Ben, what are the formats that you've seen work well?
I think it really depends on the team and the processes and tooling that the team has available to them. So in a very junior team, I always recommend pair spikes, where say we have a team of 10 people, and if I'm the TL of that team, the technical lead, I would say I want a senior person and a junior person to pair up and try to do a mini hackathon to investigate this thing. And that way, both people benefit. The less experienced person sometimes asks questions that the more senior person might not consider because of their inherent bias and their experience. It sometimes blinds you. And then the more junior person is going to just see a more senior person do things, and they can kind of absorb all that stuff. You're like, wow, I learned so much from doing this. It helps to, from a team process perspective, doing stuff like that helps to break down the false and assumed barriers there are between more experienced people and less experienced people. For extremely senior teams that I've been on, where the person with the least amount of experience on the team has been doing it for 12 years, pairing that usually is pointless with respect to executing something that you're going to deliver to the team, even on extremely short periods of time. So in that scenario, because of the speed at which everybody works and how quickly they can gain insights from that brief research period, just doing a live coding session I've seen work really well in that situation. For anything that's of sufficient scope that you can't time box in a short period of time, where it's like, hey, regardless of the experience of the team, what we're trying to investigate requires reading a lot, as well as writing code and going through examples and demos and checking advanced functionality within this library. You're not going to do that with your whole development team sitting in a room, because that might take 12 hours, might take 20 hours or something. You're not going to have everybody just do that all sprint long.
Yeah, so there's tons of different ways to go about it. I think it might be helpful to sort of give a couple tangible examples of things that have worked well in our experience. I'll start off really quick. One example was we had a rotating Hermit implementation of SetSpike, and it was just one person working on engagement classifications for different types of users. And this was really, really effective and is actually one of the most widely used data science built models in the organization. And basically what happened is the researcher identified the problem and said, hey, we don't know if different types of users behave differently. Let's explore that. So then they went in, did a bunch of EDA, and then said, hey, well, let's try to throw some unsupervised learning at it. Eventually settled on a hidden Markov model, and then was able to classify users into 3 different engagement states with a couple others added on from logical continuation of that implementation. And this included clustering on just 3 variables. So it was really, really easy to implement with SQL, so it could be built into all of the tables, and that helped it be used widely throughout the organization. So that's one example. And another example is we were working on, as I sort of mentioned before, attributing different teams and different initiatives to the overall bottom line of growth. So are we doing better or worse because of COVID, or because this PM has this new feature that's so good that everybody's flocking to the feature or to the website for it? So that second one, it was just a really tough problem. It was really not well scoped prior to the hackathon. And we had lots of really cool ideas, but we didn't end up finalizing a production solution. Lots of things were thrown around, but nothing actually came to fruition. So those are just a couple examples of, and that was at a media company. But Ben, do you have some examples on your end?
So I can talk from 2 separate perspectives here because of the ludicrous journey that I've made on my career. So from an analytics and pure data science perspective, where when I was working on teams like that, where we would get a business problem that it might be highly detailed what the problem is. And of course, when somebody gives you a problem like that, they're going to give you a solution that they think is going to work. It's almost guaranteed to happen. It's all about being creative when you're thinking about what the actual problem is. Like, how are they seeing that this is a problem? What data are they using that inform them to tell me that my team needs to work on this? So that we can start exploring data and looking at relationships and seeing, like, hey, do we have the right data for this? How often do we collect it? How clean is it? Before even looking at, oh, wow, we could build this model with this sort of algorithm. Like, I don't care. In those situations, that's implementation detail. It's all about, can we even solve this problem that they're saying is a problem? Can I validate that this actually is a problem with data? And that's what the spike would be focused on for me, at least the first phase one. And after that validation stage, I would usually take on that sort of work as a TL to save the time of the team. And then if we get to the conclusion of, this is really a problem, we need to do something about this, I might, during that process, think of things of how to solve that. And based on my experience, I would be always searching for the simplest way to solve it, because I don't like maintaining code I don't need to maintain. So the easier it is, the better, in my book. But I'm not going to say any of that to the rest of the team. I'm going to present it as if I'm completely ignorant of what's going on and let them get creative. Just present the problem. Like, hey, here's the data that we should be looking at here. Here's the problem that the business is struggling with. Everybody, take 4 hours and see what you can do. What can you find? And then we'll meet back up this afternoon after lunch and let's talk through it for an hour. Everybody present some data, present your notebooks. And at no point is the expectation that the code is clean or, well written. For this sort of work, be as dirty and nasty as you have to be. It's all about speed and exploring as much as you can. From a software engineering side, it's very different, that process of evaluating a problem. Evaluating a problem at that point, you usually have direct evidence or requests that people have saying, we want a feature that does X. Now, that's as far as it usually goes, and that's as far as it usually should go, because the people asking for it aren't going to know how to implement it. They don't need to know how to implement it. It's not their job. It's the job of the development team to get creative and figure out a way to solve this problem. But the determining ways to solve it, there's different stages of that. So stage one is, what's the grand scope of what we need to do, and what is in scope and what is out of scope? What is that minimum viable product that we need to build? And determining that is what you figure out by doing a rough spike. Like, hey, we need to integrate with this API, this open source tooling. How does this thing even work? Like, can I go through their docs? Can I read through their examples? And do they even run? If I copy the code from their website and paste it into an execution environment and run it, does it throw an exception? That sort of thought process of, is this functional? Can I use this to solve this problem? I might be testing 3 different packages to solve this problem, if we're talking about ML engineering integration. And then after that, you might go through and say, okay, on the non-example data, let's take an actual tutorial on real data. Maybe the data is provided by the package for you. Well, check it out, look at it. Is it legit? Have they done something funny to it? Are they only using integers and there's no floating point units in here? Are they, pre-casting categoricals to integers or something, or index values? Take a look at all that stuff and then be like, all right, now I'm going to take it on some real data that we have internally and try to run it through this package. And then later on, after everybody in the team, or, if it's a limited number of people doing that investigation, that's when you start talking about, okay, here's 3 ways that we can do this. We evaluated these 3 approaches. Here's the pros and cons of each. And this is the direction we're going to move in. Only after that is done and the team sort of agrees on, hey, this is kind of what we're going to be doing, then you start worrying about implementation details and planning out, like, what do we actually need to build here, and thinking through, what does the architecture of the code need to look like? Are we going to be using these principles in constructing this? How does this interface with the rest of our software that we're adding this to? So it becomes very different. But after that initial spike phase, in both scenarios, whether it's pure software engineering or, data science work, ML work, I've always been a fan of not worrying about implementation details until after peer review of the idea. So you get to that peer review phase and people are like, okay, you tested out these 4 different models for data science type stuff, 4 different approaches. It Doesn't have to be perfect, doesn't have to be tuned, doesn't have to be, it has to be trained, of course, but it doesn't have to be, run through hyperparameter tuning and be like, hey, we got the best RMSE with this particular solution. Who cares? It doesn't matter. Like, you'll tune that later on. That's an implementation detail. The spike is to figure out, can we solve this? Yes or no? Basically, the time that we would be committing for the next n number of days, weeks, or months, is it worthwhile? Is it more important than other things that we could be doing?
One thing that is really interesting that I would love to get your opinion on, Ben, is how you approach developing the simplest solution. So putting some like a face to the name for that question, there often is this human drive to get something to work, right? And get something fancy to work, especially if you're more junior. It's really enticing to throw deep learning at everything. What part of your career and what lessons have you learned that make you try to simplify problems? Is it getting burned in the past on maintaining code? Is it why do you do that?
It's a huge collection of maintaining crap code that I've written in the past and struggling with keeping it running. The more complex that you write something and the less amount of peers that look at your implementation before it becomes production, the higher the probability that you're the one who's going to be maintaining it alone, which is a danger. You don't ever want to be that person who does something that, makes you feel good about your skills and, massages the ego of like, yeah, I'm good. Look at how complex of an implementation I built here. This is awesome. And you might have some buddies at work that are like, hey, that's pretty cool. That's fascinating. That's amazing. Anybody saying that to you on something that's complex, they're never going to maintain that. They're never even going to help you maintain that. So don't ever ask for people to praise your work on something that's clever. The peers that you should be looking for on reviewing something are the people who are on call. They're the ones who realize that they have to maintain what you built, and they're going to look at it through that critical eye. So I've learned that process. I don't know if it's something you learn in its entirety. It's something you always learn. You're always continually learning whenever you're writing code and working in different teams. You're going to learn different aspects of this, but you'll really feel the pain, not only with your own code, and that's a humbling experience when you realize that you've written something that's hot garbage, that breaks often. And it's truly humbling when you look at something that's failed, and it's the first time it's failed in 6 months. You look back at the code base, maybe not remembering who wrote it, but you look at it and you're like, I can't read this. I don't know how this works. What idiot wrote this thing like this complex? And then you look at the commit history and you're like, oh, I'm the idiot. Man, what the hell was I thinking? Because if you have to reverse engineer your own code, that's bad, right? So I've been in that situation before where I've looked at something that I built a year before, and I'm baffled at just the hubris that I had when I wrote that, of thinking like, hey, this is a good idea. Look at how cool this is. And then looking at it a year later when it breaks, I'm like, what the hell? Like, this is so bad. It would take less time to rewrite this from scratch properly than to fix this convoluted mess that I've created. So I've learned that lesson the hard way. It's frustrating in a different way when you're on call supporting somebody else's implementation and you look at it and you're like, wow, am I stupid, or do I just not know enough about how this language can be used? And you're kind of reading through it and, frustrated because you have to fix this thing because it's a production down process. And then you ask a peer, or maybe you ask somebody who's more senior, like, hey, can you help me take a look at this? And then they get that same look on their face and you're like, okay, it's not just me. Like, this sucks. This is not written right. And then realizing the person that wrote it left the company, and you realize that in order to fix this, you have to rewrite the job or rewrite the project or something. And that feels bad.
Hey there, this is Charles Maxwood. I'm excited because I wanted to let you know about this thing that I pulled together that I've been dying to have this for years, and I never felt like I could. And then I just realized that there's no reason why I can't. So I'm putting together a book club, and we're going to read development-focused books, career books, technical books, whatever. The first book that we're going to do is going to be Clean Architecture by Uncle Bob Martin. If you're not familiar with Clean Code or some of the other stuff that Bob has done, check that out. I've also talked to him on the Clean Coders podcast, which is on Top End Devs. But we're going to get on. He's going to show up to some of our meetings. And what I'm thinking is we'll probably have like 5 or 6 people part of the conversation along with Bob and I at the same time. And we'll just, so somebody can come on, they can ask their question, and we'll just rotate people through. So we'll mute one person, unmute another person when it's their turn to come on and be part of the discussion. So we'll do that for like an hour, hour and a half. And then the other part of it that I'm putting together is just kind of a meet and greet gather area on GatherTown. And so after the meetup and the call, what we'll do is we'll all go over to GatherTown, and you can just log in, walk up to a group and have a conversation. And that way we can all kind of get to know each other and make friends and get to know people across the world. One thing that I'm finding is that, the meetups are starting to come back, but a lot of people don't have the opportunity to go to a meetup. And I really want to meet you guys and talk to you. So we're going to put all that together. It'll all be part of that book club. You can go to topenddevs.com/book club to be part of it. And I'm looking forward to seeing you there. The first book club meeting will be in December, the beginning of December. We're starting the first week of December. And you'll also be part of the conversation about which book we do next. I have one in mind, but I want to see where everybody's at. So there you go.
Yeah, getting lots of eyes on a problem is really, really helpful, especially from experienced people like Ben who have learned that maintaining code sucks. It really can help with a lot of things. And sometimes, just taking a very simple modeling example, a 2% drop in accuracy is worth the amount of man and woman hours it would take to maintain that much more complex production version. So there's a lot of things that go into making the decision for what should be put into production and what shouldn't.
Yeah, and you mentioned that junior data scientists wanted to use deep learning. I do have a lot of opinions on this that probably aren't that popular, but I'm a huge fan of deep learning. I think it's amazing. It is this awesome tool set and paradigm that you can use to do things that other implementations or other algorithms are just completely incapable of doing. That being said, if all you have is a hammer, everything looks like a nail. And if you apply that advanced tooling to every single problem that you come up against, I know the argument might, and I've received this argument from junior people before, like, well, I can use TensorFlow for every problem. Like, yeah, you can, but who's paying the bill? So depending on what resources you have available to solve a problem that could be solved with, say, logistic regression, and you could get a pretty good result, generalizable results for a supervised learning problem, where you're just predicting a probability of class membership. And could you use, deep learning for that? Of course, it's completely suited for that. But that logistic regression model will train on a 4-core CPU in 30 seconds. And then retraining that deep learning model to get 30-second response time, you might need to have a pretty expensive, tensor processing unit or a GPU available. And when you're talking about how many iterations you're going to have to do while developing that solution, it's not people like to think of how long does it take to train one model. Like, well, it's only 5 minutes to retrain it. Yeah, well, how many times are you going to do that 5-minute retraining while you're building this project? 2,000, 5,000, 10,000? I don't know about you, but I try out a lot of stupid ideas whenever I've built ML implementations. Sometimes I just read through the APIs. I'm like, I wonder what happens if I try this. Well, all of those what happens if I try this iterations, they all start to add up. And computing resources are not free if you're talking about cloud-based things. If you're talking about on-prem servers, where your IT department is maintaining some machines for you to do testing on, which there's not that many companies that have server farms that they control anymore. But if you do, you're taking resources from somebody else when you submit that job. And if you're doing it on your laptop, shame on you. You should only do that for research and learning, or local unit testing. But if you're doing something that's eventually become a project that's going to run in production services at your company, you should be doing that in a proper development environment, which that costs money.
Yeah, and one more pitch on like the anti-deep learning wave, especially since we're talking about spikes. Spikes are short research projects that have a finite amount of time to deliver a result or deliver something that should not be a result. And that's sometimes equally valuable, like knowing that this solution is not viable for this problem. When you are in that research phase, iteration is so freaking valuable. And if you're using complex models, your iteration time is often a lot slower because the model takes a lot longer to train. If I can write a SQL case statement, I can try 1,000 case statements in a day, let's say. That's a lot, but a couple hundred in a day and see if they work. And then throw it through a loop in Python. Now I can try 100,000 case statements. All of that will run super, super fast. But if you immediately jump to complex solutions, you don't have a starting place and you don't have, therefore, a place to continue from or to keep iterating upon. So if you are trying to get results, iteration I found is super, super valuable and super, super effective. And big complex models should usually be a last resort unless you know that the implementation or the subject matter of that ML algorithm warrants deep learning. But Ben, I have a question for you. So you've been part of a few spikes. What are a couple traits that you see in ML engineers that make them very good at spikes, and a couple traits in ML engineers that you see that make them very bad at spikes? Whether it be personality, skill set, you name it.
Good traits, I would say, can the person see the forest for the trees? Like while they're going through research, they're just hitting the main points. So instead of, again, we're talking about retraining pre-trained deep learning models. Somebody that can see the forest for the trees might take, to evaluate what it's like to retrain, they might take an open source data set that might have 10 billion records in it, download it, get it all ready. The person who can see the bigger picture is going to take 10 rows of that data and issue it a single epoch retraining just to see what it does. Does it update weights? Yes or no? Do I see a result on TensorBoard? Can I open that up? How does it look? What happens if I just change this parameter on 10 rows of data? What does that change? What happens if I change my optimizer? You go through and do a bunch of these validations on just random selection of data. You're validating that, what the feel of everything is. What is my code going to look like? How is it going to be to interact with this API? Is this something I want to take on? The person who can't see the forest for the trees is going to take that open source retraining data set and they're going to hit retrain on all of it. And they're going to check, okay, what does 50 epochs of retraining look like? I want to validate all of my results on TensorBoard. I want to put a loss function in here, custom loss function. I want to be able to see what my metrics are across all of these different parameters for testing things. They're doing implementation details while doing research. That's what that is. So if you're worrying about the entire API and what an end-to-end, effectively an integration test is, that's not what a spike is for. Spike is, does this API suck? Is this a pain to do? Or is this something that it's pretty good? It's well designed. The API is kind of easy to use. It's well documented. I think this is going to, work for us. Yeah. And then also a bit of humility. People that don't take themselves too seriously when they're going through and evaluating stuff, like not taking things personally. If you can't figure something out, it's not productive. If you get frustrated and annoyed and blame the API, it seems like I've seen that happen in research spikes before, where somebody just trashes this API or says like, there are times when that's justified. There are some bad implementations out there in open source where you kind of look at it and you're like, yeah, this is broken. But the person that focuses on that and just wants to waste too much time providing evidence of why something sucks, they're not going to be able to think about other alternatives. They're going to focus sort of negative emotions and on how bad this thing sucks or how much they don't like this thing. It's like, whatever, just move on to the next thing, test something else out. You got, 4 hours to do this. And people that are successful in doing that research can just iterate fast, get the data that they need to make an informed decision, and then work on presenting those findings to the team.
Yeah, I think you hit the nail on the head when you said 4 hours. It's time boxed. So you need to be able to perform under pressure. Getting frustrated almost never helps. If you have perfectionist traits, that's also not ideal. Just quick aside, sometime in college, I built a website because, you need a website for your resume to look cool. And also websites are fun, yada, yada. I started building the website and I look up and I realize I have spent the past 90 minutes aligning footer text on an otherwise empty website. And I was just like, what the hell is wrong with me? I need to get my life together. And knowing that about yourself is actually really, really valuable because I never make that mistake now because I know I need to consciously counteract it. If I had all the time in the world, I would go super deep and make things perfect. But having some self-awareness about your style of working can be really beneficial in these time-constrained activities. And so that's one thing. If you're a perfectionist, know that and kind of like work on that. And then a second thing that we sort of hinted at before that I think is really, really valuable is being able to iterate and being okay with sort of a rough outline of the solution. But Ben definitely hit the nail on the head that if you can see the big picture, it allows you to move more dynamically in the solution space. You might be like, oh, maybe we can reframe the problem as classification instead of regression or whatever it may be. So to that end, Ben, what % of the time has the most effective solution reframed the problem versus found a clever implementation to the existing problem? And I think for software, problems are more clearly defined. It's like build this, but let's stick with data science, whether it be decision science, machine learning, that type of thing.
So I thought that about software before I started doing it full time. There's a lot more creativity and implementations in software engineering, particularly like SaaS tooling, than you assume there is as a user of it. There's a lot of really clever things, particularly in companies like the one that we work for. Engineering teams are absolutely brilliant, but also humble. It's amazing seeing them work. But finding something during research that changes, that exacts a paradigm shift that changes the entire approach. I'd say when I was more junior, that was more frequent. And the more experience that you get, the less that ends up happening. But that isn't to say that it doesn't happen. And you should be open for that happening. Even if you are super experienced and you're like, hey, I've solved this problem before. There could be something that you have in your structured list, which that also goes to say, before you start a spike, have a plan, like have a game plan of, hey, here's the things that I need to check. I don't need to check them beforehand, and I shouldn't do that, but here's a list of things that I need to check out. Basic research and preparation. But if you've come across something that is so much simpler to do it that way and still solves the problem than what you've done in the past, yeah, definitely be open for that. And I'd say that's about 10% of the time that happens for the stuff that I worked on in like the last 2 years that I was doing data science work. But then the flip side of that coin of I don't find a solution that's readily available out in the open source world or in some service that I can sign up for and buy to solve it, that's probably also on that 10% spectrum with the same ratio, but not as a beginner. As a beginner, that was 0%, because you wouldn't know, if you're new to data science and ML or software, you're not going to have the skills or the capabilities to build something from scratch. You might think you do, but newsflash, spoiler alert, you don't. It's not going to be something that's going to be any good, probably.
We don't have to hurt everybody's feelings just because it's true.
I mean, from my own experience, I did attempt to do stuff like before I was ready to do it, and built stuff that I'm like, wow, that sucks. Like I'm annoyed that I spent a month on this and it went nowhere, because it didn't cover all of the cases, or it didn't run in this environment, or it created, the implementation was not performant in a way that we could run it in production. It was like too expensive or something. So it just takes time to learn all that stuff. And you learn that by seeing open source tooling and seeing how they're implemented and learn from that. Everybody kind of learns that way. So it went from 0% to it ramped up relatively high when I was sort of medium level experience in my career within data science, where I suddenly thought that, open source tools can't do this. I need to build something myself. So there are still, I'm sure at previous companies I worked at, some of these things are still running today. They probably shouldn't be, but things that there is a solution in the open source, pantheon out there that could have been used and should have been used, but I might not have liked its APIs, or I might have thought, well, not that I can do it better, but I want to learn how to do this sort of thing. So I'm going to implement something myself so that I don't have a dependency on this package, which is just stupid. It was dumb of me to do that. And it was probably for pride as well, to show like, hey, I can do this. I can create my own implementation of this, algorithm. If I could go back and tell myself now, like, hey, if you want to do that, cool, man, like do that on the weekends, or like do that at night. Don't push that to a company's code repository. Do the simpler thing. If you want to learn how to do that, how to build this algorithm, then just learn how to build the algorithm and do it at home on your own computer. And don't waste all that time trying to get it working in your production environment when it's 3 lines of import statements and then 30 lines of a function that you can just interface with this open source package and do the exact same thing. And it's maintained by, 400 people on the open source community. It's easier, it's faster, and it's probably going to work for a lot longer period of time. And you don't have to maintain it, which is the big bonus. And then, fast forward to now with respect to implementations of me not finding something that could potentially solve it and saying like, hey, okay, I need to build this. For data science work, pretty much never happens. Or it's so infrequent. For solving an actual modeling problem, one time in the last 2 years did I actually have to build a custom algorithm. And that was simply because it didn't exist. And I knew it didn't exist because a customer showed me a PDF of a white paper that had been published 6 months before. And they said, we need this on Apache Spark. And I'm like, yeah, that does not exist because nobody's built it yet. So yeah, we can work on this together and see what you need of this. But first you need to prove to me that you do need this algorithm and nothing else is going to work. And they did that. And then we built it together. But that's exceptionally rare. And it's usually for highly esoteric problems where it's like, okay, this package might exist or the solution might exist on single node machines. It's not a concurrent process or a parallelizable process. But there usage of this and their data set volume that they need in order to train a model, it has to be distributed because you can't spin up a VM that can hold that much data in it to actually run the algorithm. If you're doing stuff like that, always ask around and do a bunch of research before you tackle something like that, because it's a lot of work and it's super fun work, but you now own that. You have to maintain that.
Have you ever wished that you had a group of people that were just as passionate about writing code as you are? I know I did. I did that for most of my career. I'd go to the meetups. I'd try and create other opportunities. And it was just really hard, right? The meetups, I got some of that, but they were only like once or twice a month. And it was just really hard to find that group of people that I connected with and really wanted to, talk about code a lot, right? I mean, I love writing code. I think it's the best. And so I've decided to create this community and create a worldwide community that we can all jump in and do it. So we're going to have 2 workshops every week. One of those or 2 of those every month are going to be Q&A calls, right? Where you can get on, you can ask me or me and another expert questions. The rest of them are going to be focused on different aspects of career or programming or things like that, right? So it'll go anywhere from like deployments and containers all the way up to managing your 401k and negotiating your benefits package. We'll cover all of it. Okay. And then we're also going to have meetups every month for your particular technology area. So we have shows about JavaScript, React, Angular, Vue, and so on. We're going to have meetups for all of those things. I'm going to revive the freelancer show. We'll have one about that, right? So you can get started freelancing or continue freelancing if that's where you're at. And I'm working on finding authors who can actually do weekly video tutorials on something for 10 minutes that's related to, again, to those technology areas so that you can stay current, keep growing. So if you're interested, go to topenddevs.com/sign up and you can get in right now for $39. When we're done, that price is going to go up to $75. And the $39 price gets you access to 2 calls per week. The full price at $150, which is going to be $75 over the next few weeks, that price is going to get you access to all of the calls and all of the tutorials and everything else that we put out from Top End Devs, along with member pricing for our remote conferences that are coming up next year. So go check it out, topenddevs.com/sign up.
As someone who doesn't have 30 years of experience in the data science field, I'm starting to learn that building stuff from scratch doesn't always work. When I was a kid, like 7th grade, I told my dad I was going to build AI. So I went upstairs and made a list of words and it would randomly put out a sentence. And I was like, look, it talks. And having sort of like knowing what you don't know is a really, really valuable thing. And as you work with smart people, you start really appreciating how difficult the difficult problems are. Like you're not that much better than anyone else or better at all.
I've never in my career actually met someone who on their own with no input from an external source build something amazing. Anything that if you're using an open source package that's in existence somewhere and there's a lot of people that use it, take a look at the PRs that are filed from the internal maintainers. Just look at them. There's going to be constructive feedback from other maintainers or people from the community on that PR. And if it's a complex PR and there's a lot of things that have been done to build that, think about what the internal process at that company or within that team was before it even got to the point where you're building a PR. They probably did a design review. They went through and got torn apart, and collaborative work of all of these amazing minds came together to build a plan to build something that'll get implemented, that'll work really well. It's always, a lot of people assume that great software or great implementations are a solo thing. They're not. It's a team effort. And you're never going to find something that's truly amazing that's just built by one person in isolation. So you shouldn't build ML implementations like that either.
Cool. So I'll do a quick recap. So today we talked about spikes. Spikes are short research projects and they can take many formats. One format that is really effective that both Ben and I have seen is pairing up. So if you have a junior and a senior person, that can be effective, or two senior people, sometimes less effective, but if there's a lot of open collaboration, that can work really well. You can also have entire team hackathons, or give a rotating hermit, let's say a week, to come up with a research project and then deliver those results. A couple benefits of spikes. We've talked about a few, but I wanted to highlight 3. So first is team morale. It's really fun to work with each other, get to know each other, etc. Second is you can save the team time by efficiently exploring what should and should not be built. And then third is you can build skills. So sometimes you aren't in a time box when you're developing solutions, and it's really fun to work under different constraints. And if you do implement spikes, here are a couple tips. Spending time getting existing code to work versus building your own solution usually is a high ROI activity. It's better to work with what's out there and what has been peer reviewed by many, many people instead of trying to build your own thing from scratch. Don't worry about productionizing until you get feedback. Also, keeping it simple is really, really effective because you're going to have to maintain it. And so if it's simple, it's easier to maintain, easier to understand, easier to iterate upon. And then from a human perspective, if you're looking to develop some traits, being able to see big picture is really, really important. Being humble is also really important. And then again, focusing on iteration is also really important. Anything else you want to add, Ben?
No, that's good.
Cool. Well, until next time, it's been Michael Burke and
Ben Wilson.
And have a good day, everyone.
Take it easy.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.